So yesterday we talked about, if you remember, like physics fundamentals and then kinematics. Kinematics kind of described how things move, and today we'll be talking about sort of like the why, like why things will move, which is what dynamics is all about. And dynamics is all also just using this one equation, F equals ma, so force equals mass times acceleration. This equation will keep popping up because it's very important in mechanics, especially dynamics. So first, we can dive into a problem, just introduce you guys to a problem. And this problem asks, there is a 10,000 kilogram truck that collides with a 1,000 kilogram car, and it asks which vehicle experiences a greater impact force. So you guys can think about this for a while. I give you guys a hint. It says Newton's like which law? So you guys can try to think of this question, but we first have to talk about what really is a force, right? We already kind of talked about what a force is because I mentioned what a force is in the context of Newton's second law, or F equals ma. But a force is just anything that causes objects to accelerate according to Newton's laws. And force can be produced by many things. So there are many different examples of force. Like the most common ones would be the gravitational force or gravity. And there are applied forces, which would be, if you see this man as like pushing a box, he is exerting a force on this box. And that force would be called an applied force because it's like literally applied by like something or some person. Just like an umbrella term for any force that we can apply on something. And then there are spring forces, which also commonly show up, but we won't really get to today. And this is an example of like different springs on the right. And when springs stretch, they produce forces. So that's how springs work. So here are just some examples of forces. All right, so here is just a sample question to make sure that you guys can understand Newton's second law, and it's just a direct application of it. So the question describes that there is a 5 kilogram ball, and you push it with a 10 Newton force. And it says that it will accelerate. And it asks you for that acceleration at which it will accelerate at. So what you want to do is just think of Newton's second law. We have two variables here. We have two variables given. There's the 10 Newton force, the force, and then we have the mass. So then the acceleration would be the only unknown. So then just applying F equals ma, we get F equals ma over here. And then we can divide both sides of the equation by m. You get a equals F over m. You solve for a, and you get 2 meters per second squared. Okay, so now returning to the problem that I first introduced you guys to. This. There was the heavy truck that collided with the little car, and then I asked which vehicle experiences a greater impact force. Now, you might be inclined to think that like the small car would probably experience a greater force because if you're in that small car, you'll like probably like fly further away or something. But that's actually incorrect because if you think back to Newton's third law, we know that these two vehicles will experience the same force because the forces that they experience from each other are action-reaction pairs. So the impact force for the big truck will be the reaction force to the impact force for the car and vice versa. So they experience the same impact force. Now, if this question asks something else, like something to do with their accelerations, then we can apply Newton's second law. Because if they're asking something about accelerations, we know that since they have the same force, we have F, like big truck equals F car or something like that. And since the truck has a much greater mass than the car, we know in order for the forces to be the same, the acceleration for the little car will be much greater than the acceleration for the truck. So applying Newton's second law, we can kind of understand how acceleration is related to force in this case. Okay, now circular motion. Circular motion is another branch of dynamics, and it's exactly what it sounds like. It's all about motion in circles in a circular path. So we can just look at this example over here, the bottom of the page. There's this man holding this string attached to a ball at the end, and this ball is traveling in a circular path. So when objects travel in a circular path, well, we have this whole branch of mechanics for it. It's called circular motion. And when they travel in a circular path, their speed could stay constant. So this kite could just make the spin at a constant speed. But something that is changing is the velocity. Because the speed can stay the same, but if the direction changes, then the velocity will change. Because if you remember, velocity is a vector. It has the speed, and a magnitude, and a direction. So now that we know that the velocity changes, we know that there must be an acceleration, because acceleration would be a change in velocity, a rate of change in velocity. So since there is an acceleration, well, we know there's an acceleration, and this acceleration is known as the centripetal acceleration, and this acceleration is pointing towards the center of the circular path. Now, we know from Newton's second law that if there's an acceleration, we know from Newton's laws as a whole that you need a force in order for something to have an acceleration. So since there's a centripetal acceleration towards the center of the circle, there must be a centripetal force pulling this towards the center of the circle. And in this case with the spring, the centripetal force would just be the tension in the spring. However, centripetal acceleration isn't an entirely new force. It's just a term to describe the force that is pulling the object towards the center. So tension could be an example of it. Some other examples of centripetal forces could be gravity. It could be like normal forces, or like pretty much any kind of force. But you might be going like, wait a minute, when you're in like a car and you round like a circular path, you might feel like you're being pulled towards the outside of the path. So why is that case? Well, that is because if you're sitting inside like the reference frame of that moving object, like you're sitting inside that car, you will feel this force pulling you to the outside, which is called the centrifugal force. This is not an actual force that you experience. So it is known as a fictitious force because it is something that you feel, but it's not actually a force that is pulling you in your emotion. So centripetal force is towards the center, and then centrifugal force is towards the outside, but it's a fictitious force.